Oftentimes when we're solving problems with mathematics, we end up with a solution or a number that needs to be put into context. So what that basically means is that our number needs to have some type of meaning behind it. In this video, we will demonstrate some examples that you might see and something that you want to look out for when you're solving said problems. First off is math is like a language, so it helps you explain the real world. So for this reason, the numbers that you obtain when you solve a problem have to be put into some sort of context. The first question says, a food pantry has 38 packages of frozen vegetables to be distributed equally among 8 families. How many packages of vegetables should the pantry give to each family? So what you would do is you would take your 38 packages of vegetables and divide them among the 8 families. So 38 divided by 8, whether you do it by hand or with a calculator, will give you 4.75 packages. However, because we can't give a family a part of a package, we have to approximate it to the nearest whole number. So if you were to approximate this, you would get approximately 4 packages. Now, the reason why we round down to 4 is because we cannot give an open package to the family. So that means in this case, we would just have, for each family, 4 packages each. So the next question says, a group of physics students are solving a projectile problem where they must find the time that an object reaches the ground. To do this, they must solve the following equation: negative 16t squared plus 10t plus 100 equals 0, where distance is in feet and time is in seconds. So to solve this question, you would apply the quadratic formula, and when they do that, they find 2 answers. T1, which is negative 2.2 seconds, and T2 equals to 2.83 seconds. Now, part of the team wants to report both answers, while the other only wants to report T2. Our question is, who is correct? To determine who is correct, the first thing we want to do is, in the context of things, is what kind of units are we operating in? Because we're working on units of time, which is in seconds, and we want to look at our 2 answers again. Our T1 was negative 2.2 seconds, and T2 is 2.83 seconds. Now, if this question was just saying, solve the equation as it is, without any other context about being a projectile or anything like that, yes, those would be our 2 answers, negative 2.2 and 2.83. But because we're talking about an actual projectile and there's actually time involved, our only logical answer here would be the T2, which is 2.836, because we cannot have negative time. Negative time does not make sense in the real world sense. We always talk about time which being positive. So that is why the people who are correct is the people who report only T2. To finish a project, Adam and Tom need 13 yards of cable. They have 2 spools, one with 9 yards and the other with 140 inches. Adam says that by putting together the cable of both spools, they should have enough. But Tom's not so sure. Is Adam right? To determine if Adam is right or not, we have to look at what we're given. We have one spool, which is 9 yards, and the other is 140 inches. So now notice both spools are in different units of measurement. So before we want to do anything with them, we want to convert them into the same units. We do that by knowing that 1 yard is equal to 36 inches. So what we want to do is we want to find how many X amount of yards is equal to the given 140 inches. So we can actually create a ratio with these two. So we can have it as 1 yard, 36 inches, and put that over the X amount of yards, equating that over 140 inches. So now we can write them without the units. We have 1 over X equals to 36 over 140. To solve for X, we cross multiply first. And when we do that, we would get 36x equals 140. To solve for x, we divide both sides by 36. That'll give us x is approximately 3.89 yards. So 140 inches is equivalent to approximately 3.89 yards. So now what Adam did is that he rounded up to the nearest whole number. That gave him 4 yards. So he said, okay, if we put them together, so we take the 9 yards from the first spool, add them to the 4 yards of the second spool that we just found, that will give him 13 yards, which is what's needed to finish the project. However, this is not the correct logic on Adam's part, because he rounded up. When he rounded up, he basically said that he's using more yards of the spool than what's available. What he should have done was round down to the nearest whole number. So 3.89 would round down to 3 yards, and then he would add up the 2 spools, which would only give him 12 yards, which is not enough to finish the project. So is Adam correct? In this case, he is not correct in his logic. Thank you for watching. If you need additional help with math, come visit us at the Math Homework Lab. We're located in room F234, and we operate as a walk-in, first come, first served basis. Thank you so much. This is some additional useful information when you're working on a project. And if you need help writing a paper, come visit the right place. We're located in G103. Thank you.